Thank you. Hi, I'm Marcus Hamster, and I'm an independent. Okay, sorry. I'm an independent software developer who's been using Python for 20 years, but this is my first PyCon, and it's great to be here. So, before I start with the meat of this talk, I would like to say that this talk is being recorded. Slides will be published, as well as the code at that URL and some additional resources which we probably will not have time to discuss in detail. And this talk is about my experience publishing packages, the process, the tools, the services that I use, and they work well for me, and I hope they will work well for you as well. But if they don't, they're easy to modify, so it shouldn't be a problem. And we will be looking at a pure Python package because of simplicity. We don't really have time for anything more complicated, and because, like most developers, I learn about packaging only slightly more than I need to. So the pure Python package that we will be working with is a fake one called PyStart. And first, let's start with the code layout. So the first thing that every package needs is a setup.py configuration file that goes into root directory of repository. It also needs to have code stored somewhere. I tend to use the same name that I want to import. So if I want to use an import statement PyStart, I would use PyStart as a directory name. Probably you don't have to do this, but why complicate if you don't have to? I also like to create two additional directories as a separate one on top level, one for tests and one for documentation. So they're easy to find if needed, and it's also easy to include or exclude them into the package itself. So the next thing is, so as I mentioned, setup.py is the configuration file of every package, and it consists of two parts. One is metadata, and the other one is packaging info required for the package to be built and be able to install it. So metadata itself is fairly straightforward, obvious what it does. So you have an author, you have a name of the package, description, and a few other bits that I think are in general self-explanatory. So let's not spend too much time on them. But I would like to point out a couple of things. One is that if you store your code on a public repository like GitHub, then it makes sense to also store description in a separate file, because this way you can reuse it on GitHub and on PyPI. And while GitHub itself doesn't really care all that much about formats, it supports, I think, about 9 of them. PyPI does, so use restructured text for your description file. The other thing to pay attention to are also the classifiers, which are at the bottom of the screen. Those classifiers that are in the format that can be easily processed by code are also something we developers use when we look for packages that are interesting to us. So make sure to pick relevant ones and to update them as needed when new Python versions come out or package reaches the next level of maturity. Well, there's another one thing I almost forgot, which is a license. And do pick one, because since Berne convention, every code is automatically copyrighted, and that effectively means it's copy locked. So nobody can do anything meaningful with it except you until you pick a license. If you want to discuss more about licenses with somebody who has no legal training whatsoever, talk to me later. Or better yet, wait for the next talk when Felix Kraks will tell all about them. So once we have a metadata section done, covered, we need to set up the package itself. And in certain cases, this is all you need. So the packages option specifies where to find code. And in this particular case, since we at the beginning said that we will store code in PyStart directory, we only need to list PyStart as a relative path to that code. Now, most packages actually need I think, have some external dependencies beyond standard library of Python. And for them, we also need to include those dependencies so that they will be installed before our package and that installation will not be broken. And so install required is a section where we list those packages. We use names that are used on PyPI together with version numbers. It's a good idea in general to limit those version numbers so that it will automatically pick up bug fix releases, but won't be too liberal because every now and then packages do introduce backward incompatible changes and your package might break. So at this point, what we have is a package that can be installed, it can be built, it can be installed locally, but we have no idea if it works yet. And for that, we need to do some testing. And while we could perform manual tests, it's in general a better idea to write executable tests that you can then run at any time, as it's far more likely that you will do so, and it's also, you're able then to expand your test suite over time with tests for bug fixes and things like that. So Python itself already comes with a testing framework called Unitest, but if you haven't invested yourself in one yet, I would recommend to look at PyTest, which is an extremely powerful and flexible framework. To get it running, all you need to do is install it with pip install PyTest, and then execute it. And once you have a few tests written, you'll get a display like this. PyTest itself will find tests almost everywhere. So as long as you have a file that starts or ends with test underscore and includes functions that start with test underscore, those will all be recognized as valid tests. So at this point, we have, I guess, a package that can be installed locally and that has some tests that we can use to make sure that everything works fine. Now, most packages we probably don't write to work with just one Python interpreter version. We want our package to work with several. And to make sure that this is actually true, we need to test with all those interpreters. And for this, we can use a tool called Tox. So if we think of Python interpreter as just another package, another dependency for our own package, then what we actually need is a tool that can create a separate testing environment for different package configurations and can run those tests automatically in all of them and collect results at the end of the run. And Tox can do all of this and much more. But to be able to use it, we need to configure it first with the tox.ini file, which basically consists of two parts, tox and testenv. So in tox, we list the test environments that we want to use in envlist with the envlist parameter. Now, tox itself comes with a long list of ready-made test environments. And in this case, those are Python 2.7, Python 3.5, and PyPy, and basically all the relevant Python versions. You can also define your own, although we don't really have time, sadly, for that. But here you just list those that you're interested in to test with. And in the next section, testenv, we need to then specify what needs to happen when the test environment gets configured and run. So first we need to specify which things need to be installed. And for us, this is just PyTest. So that's what we list in dependency list. And in commands list, we specify which command to run once the dependencies have been installed, which for us is just normal PyTest. And once we've done this, we can run tox, which will create a test environment for each of the specified interpreters, run tests, install dependencies in those environments and run them, and you'll get a display like this. So at the end, we can see that tests in all three of them were successful. So at this point, we are at the point where we have a package that can be installed, that can be tested in multiple environments. But wouldn't it be nice if the tests ran every time we make a change that we want to keep? And we can actually do this with something called Travis CI. It's a tool. It's a continuous integration service at travisci.org that you can use for public repositories or private if you're willing to pay. And what it does is that it can automatically, every time you push to GitHub, it can run tests for you. And pushing to GitHub is sort of a, commits that we push to GitHub are those, I guess, we want to keep. So this is also matches well with the expectations. So to use Travis CI org, we need to create an account. And that means that we need to, we go to that URL, log in with our GitHub account. We need to then authorize the application to have access to our repositories. Once we've done this, we get to the list of our repositories. If it's not complete, we need to just click sync in the top right corner, and then we switch those on that we want to handle with Travis. So once we've done this, we also need to set up Travis in our repository with, so we need to write a Travis configuration file, such as this. This is from one of my projects, slightly simplified. And the first line in this file is specifying which language we want to use. So in our case, this is a Python. And the next few lines, so the metrics part, is the, so Travis can run, can execute tests in multiple, with multiple interpreters. But at the same time, we already use docs to do this locally. And it's a good idea to also do it on Travis, because this way the test will run more quickly, because each interpreter will run in parallel with others. And also, the results that we have will be more readable, because we can see which ones failed more easily. But the problem is that then Travis and Togs need to know which one to use. So here, what we do is in include, we specified Python version for Travis with Python attribute. So an example is 2.7. And then we direct Togs to use just the Py 2.27 environment by setting Togs env variable, environmental variable with env parameter. So this way, Travis will use 2.7, and Togs will know from Togs env that to use Python Py 2.7 environment, and this way everything works just as we would like. But it is important that those names actually match those that are used in Togs, because otherwise, obviously, it can't know which one to use. So once we've taken care of this, we also need to take care of setting up the environment. Since we delegated more or less everything to Togs, we just need to install Togs itself with pip install Togs. And once it's installed, we need to specify commands to run. And for us, again, this is just running Togs as it is. And at that point, we might, once we make the next push to GitHub, the test will run, and we can get a page like this, listing results of how successful or not they were. And we also have a badge that we can include to let other developers know how well we are doing. If we click on that badge, we can get embed codes that we can use to add to our README file and things. So at this point, we have tests that run locally in multiple environments. They also run automatically every time we push new changes. But we don't yet know how much of our code they actually cover. A passing test suite is nice, but it's no use if it just tests a minor part of the project. So to counter that, we want to also collect coverage information, which is information that tells us how much of our code is covered with tests. And we use coverage module, an excellent one as well, for this, to make it work. Before I go into installing, what I want to say is that coverage by itself doesn't tell us that there are no bugs if we have full coverage. But if the coverage is low, we do know that there are significant parts of our code where we just don't know how well it works. To use it, we need to pip install pytest-cov to integrate it with the PyTest framework. And once we run PyTest, we just need to use -cov parameter to also collect the coverage information. Now, before I actually show an example of this, let's make another change. So create another configuration file in root repository of our package and add two parameters. So source parameter limits collecting of coverage just to the directory pystart. This is a relative path to our code, because in general, we're not interested in coverage of tests and other bits of code that we haven't written. The branch, what it does is that it shows, with branch set to true, we also cover affirmative and negative statements, if statements, so that all branches of code get covered. So once we've done this, we can run pytest-cov with the cov parameter, and we get a table like this that shows coverage information. We can also include this into a talks, so that we can gather this information also for different configuration testing environments. And to do this with the talks, we need to add pytest-cov as a dependency, and we need to change command to include the cov parameter. And so now we're getting information about coverage locally when we run tests on our machines. But again, wouldn't it be nice if we could also show this information to developers who want to use our package and might want to know how well it is covered with tests. And we can do this with another service called coveralls.io. Getting an account is very similar to Travis. So you log in with a GitHub account, you authorize it to access your repositories, and then you get to the list of repositories where you need to flick those that turn on those that you're interested to monitor. You might get a page like this asking you for a subscription. In case you don't want to do that yet, you just have to click repos in the left top corner, get to this page, and then click on the add repo in the top right corner, so you can add the repositories that you're interested in. But the thing is, coveralls can't access Travis page or environments. So to make everything work correctly, we need to instruct Travis itself to send this information to coveralls. So we need to change Travis configuration file to do this. So first, we need to install coveralls module package, which is really just installs the code and utility that needs to be called to send the data. And we need to also add after success coveralls. What it does is that after Travis has completed running the tests successfully, it will call coveralls command that will also send the results to coveralls service. There's an alternative also called after failure. So we could also send coverage information when tests fail, because in this case, they just happen when the test pass. This test suite passes successfully. But personally, in my opinion, if you have a failing test suite, you should really fix that first before you worry too much about coverage itself. But anyway, you can just add it if you want to. And after you've done this, you might get a page like this. Again, listing how successful your last few runs were, with some additional information about how much it's covered. And again, there's a badge in the top right corner that you can use with embed snippets that you can use to add this information to your documentation so that other developers can see how well you're doing. Now, at this point, we have a locally installable package that gets tested every time we push changes, and it also collects information about coverage. But if we publish this package, I'm guessing we wouldn't be inclined to use it if it wasn't ours or it wasn't sort of a package of last resort. And the reason for this is that it doesn't have a documentation yet. And if you have a choice between packages that have ample documentation and one that has just a short blurb with a couple of examples, we probably will first start with the one with a good documentation. And writing documentation has also other benefits. I think Daniel mentioned a few of them before. Sadly, I missed most of the talk, but so I might repeat what he said. So what documentation does is help us design the software. If we write documentation first, we also think about how this software is supposed to be used. And it also works really well for marketing, because when we explain how to use software, we are also explaining what this software does, and we are also showing that we actually care more than bare minimum. So let's publish some docs, and let's publish them on the website called readthedocs.org, which is, I think, quite popular. We need to create an account there, and I will skip it because registering an account is easier than registering for PyCon, and we're all here. So, so once we registered an account, we get a page like this. And again, we need to connect to GitHub, so it will be able to read the repositories and get documentation from there. So we need to authorize and authorize the service. And once we've done that, we come to a very similar looking page where we need to import a project and then get to a list of projects, which for me, for some reason, is always kind of empty. And if it is, you just click the sync button right at the top of the screen, and then you will get a list. And after you click plus, you will get a page like this. Usually the defaults are pretty good. I mean, you don't really need to change them, except maybe name might be something more meaningful. But if you do change them later on, do keep the documentation type as Sphinx HTML, because this is the tool that we will be using. And once you've done all this, you will get a page like this telling you the current status and also the URLs to the documentation in the top right corner. Bottom right corner. So once we've done this, once we've set up the read the docs part, we need to do it also locally. And we first need to install Sphinx and Sphinx Autobuild packages. And we'll be using restructured text. So Sphinx is a documentation tool that Python uses itself. And so once we've done this, we switch to the documentation directory, and we run Sphinx Quick Start, which will ask us a few easy answerable questions. And when we don't know the answer, the defaults are fine. And it will generate a configuration file .py, where we should check that we also have these two extensions. So the first extension, called Autodoc, what it does is it can generate documentation from Python doc streams, which is really useful if you want to generate API documentation from your code. And the second one, Interthings, what it does is enables you to reference documentation, parts of documentation of other packages. So once we've done this, we need to write a bit of documentation, or a lot, ideally, in the structured text. We don't really have time to go into this, so let's skip this. And once we've done this, with make HTML, we can build a local version, so we can see it, but we don't have to check it in because read the docs will generate its own version anyway. So at this point, we now have a package that we can install that's tested, it's documented. It just, the only problem it has is that people can't install it. Or that's not completely true. Pip does support GitHub, so we could install it from there, but we would be very limited in a way that we can do this. Since we could only either install the latest version or version fixed to a particular commit. And we couldn't, for example, install the latest bug fix for a certain version of package. So to actually enable everyone else to be able to install our package, we need to publish it on PyPI, or Cheese Shop, as it used to be called, which is Python's one-stop shop for packages. And again, we need to create an account there, either on the website itself or during the registration, package registration process. And we already have everything we need to initiate that registration. So we just need to run python setup.py with a register command, and it will ask us for PyPI credentials. Or if we don't have them, we can create an account at that point. And once we have registered our package, we can push it, we can publish it with this command, which will send source distribution and will distribution. It will upload it to PyPI. Now, if we don't want to write PyPR credentials every time, we can store some of it in configuration file. But unless you have misplaced trust in security of your computer, you really shouldn't store your password in this file. Just put username and type password every time you have to. So this is mostly it. So we can now publish our package that's well tested, it's well documented. But now that we know how to do this, it would be kind of silly to do this manually every time we want to publish a new one, and I hope we will publish more than one. And so let's try to automate this as well. And the tool to do this is an excellent application called Cookie Cutter by Audrey Roy Greenfeld, which is for those who are not familiar with Cookie Cutter, it's a command line utility that creates scaffolding for a project from project templates. And Audrey also wrote one for creating Python package, which I slightly modified, so it includes all the bits that I talked about. And to use it, we first need to install Cookie Cutter itself. And once we have a Cookie Cutter, we just run it with the name of the template that we want to use, and it's smart enough that it can pick it from GitHub. And then we have to answer a few questions, and afterwards we have project template ready to be used. Now, there was a lot we didn't have time to cover. We couldn't create packages mixed Python code with C or some other. We didn't look into shell scripts. We had a very cursory look of the tools that were described, and I urge you to look into the documentation because they offer so much more. We also didn't have time to look at alternatives, and there are many. So if you, for some reason, you don't like any of the tools, or some of the tools that I mentioned, you can replace it very easily with alternatives. And that's it. That's all. If you have any questions or just looking for a versatile, experienced developer, then please contact me after the talk. Thank you all for coming. Okay.
Yeah. So my understanding is that you're not supposed to use setup upload because it's not as secure as, say, Twine or Click. I've heard there's some security issues with using the setup.py upload.
You know, I have no idea. I don't know. I've been using it completely unaware of this problem. So
You might want to check that out. That's one of the things they're saying in the packaging.
yes. So the thing is, the Python template, the Audrey's template or modified my version, actually doesn't push it in this, let's say, old way. It uses GitHub to automatically, once you deploy it, it will automatically also deploy it. And I think it does it differently. So you're probably fine if you use the template that was mentioned at the end of the talk. But yeah, I will definitely look into it. Thank you. Is that it?
Any question? We have one more question.
Okay.
How consistent is the documentation created by coveralls and by the local? The same documentation, or does it vary significantly?
Sorry? How consistent is the documentation created? You mean by read the docs and the local one? It's the same. So,
You say Google, is it coveralls?
well, coveralls is the one that's is a service that you use for collecting coverage information, and the documentation is the read the docs. But it uses the same. It uses your configuration file, so it will generate the same one. Okay. Well, thank you again.
So thank you.